Hello everyone. In the previous video we discussed what is flip-flop and working of SR latch using NOR gate. So continue with that. In this video I will be discussing the different types of flip-flops. So first let's consider SR flip-flop. So in latch, spurious inputs can cause output change at time, because here you can see here this is the SR flip-flop. So if you consider this part of the circuit, it is SR latch. For the latch circuit, we added two more AND gate with clock pulse. So here clock pulse ensures that inputs are applied only when the clock pulse is present. Otherwise, the inputs will not be applied. In the case of latch, there was no clock pulse, so that the inputs can cause output changes at any time. So now we'll consider this circuit. This is the logic diagram or logic circuit of SR flip-flop. So here R and S are the inputs and clock is applied for both the AND gates, and this output of both AND gates are connected to the latch, and again here two outputs and those are complementary, Q and Q bar, and this is the SR flip-flop symbol. So here S R and this is the clock input Q and Q bar. So here clock can be a positive edge of clock or negative edge of the clock. So for example, so here actually this is the positive edge of the clock, so that means the output will changes during the positive edge of the clock pulse. But if you consider the negative edge, during the negative edge of the clock pulse, the output will changes. So that is, this is the negative edge. So whenever you are using the negative edge, the symbol will be something different. So we'll add the bubble at the clock input. So let's consider the positive edge of the clock pulse. So now this is the truth table of SR flip-flop. So which already we discussed this in the previous video. The truth table is same as the latch. Only difference between the SR latch and this SR flip-flop is, so here there is a control input called as clock pulse. That means it ensures the inputs are applied only when the clock pulse is present. And the characteristic equation of this SR flip-flop, that is Qn plus 1 equal to S Q bar plus R bar Qn. And next, JK flip-flop. JK is a modification of SR flip-flop for invalid input combinations. In the SR flip-flop, already we know that 1 1 are the invalid input combinations, because for 1 1 input we will get the invalid outputs, that is we will get both 0 0. Hence this 1 1 combination is invalid combination in the SR flip-flop. But in JK flip-flop we can remove this invalid input combination. So this is the logic diagram of JK flip-flop. So just for SR flip-flop, we are using the AND gate, and the output of AND gate is connected to the SR flip-flop, so that we'll get the JK flip-flop. So how we are connecting the AND gate? Let's see here. So for the first AND gate, one input is J, another input is the complementary output of the SR flip-flop. You can see here the complementary output is connected to the AND gate of input of this AND gate, and for another AND gate, one input is K and another input is output of this Q, right? So now the operation of this JK flip-flop similar to the SR flip-flop which we discussed in the previous case, but let's consider how it removes the invalid input combinations. Let's see. So that means when J and K both are 1 1, what will be the output? We'll see. In the case of SR flip-flop, when S and R both are 1 1, outputs are invalid. Let's see what happens in this JK flip-flop. So let's consider, I consider the initial value of Q and Q bar are 0 and 1 respectively, and let's see what will be the next state. So now here J is 1, and for this AND gate Q bar is connected. Q bar value is 1 now, so that means this input is also 1. So 1 and 1 is 1. The output of this AND gate is 1 now, and the output of this AND gate is, so here K value is 1 and Q value is 0, so that is connected here. So that means now this input is 0. So 1 and 0 is 0. So now in other way we can say S input is 1, R input is 0. So already we know that if S is 1, R is 0, the output Q is 1 and Q bar is 0. That is set condition. You can see here. When S is 0, R is 0, Q is 1. That is in the set condition. So here now S is 1, R is 0, hence this Q becomes now 1 and Q bar becomes 0. Right? You can see here. So when J and K both are 1 1, so I consider Q 0, so the next state becomes 1. Right? So let's consider another condition, that is when J1 K1. So previously I considered Q0 and Q bar 1. So now I will consider Q1 and Q bar 0. Let's see what will be the next state. So now J1 and Q bar 0. So this input is 0 now. So 1 and 0 is now the output of this AND gate 0. And next K1, and here Q is 1. So this input is 1 and the output of this AND gate is 1 now. So now S input is 0, R input is 1. So already we know that in the SR flip-flop, if R is 1, S is 0, the flip-flop is in the reset condition, that is Q value will be 0. You can see in the previous slide. So S0, R1, the output is 0. The flip-flop is in the reset condition. So now Q value becomes 0 and Q bar value becomes 1. So that you can say here, when J1, K1, if you consider Q value 1, so the next state becomes 0. So that means here, when J and K both are 1 1, the output toggles. Toggling means if the previous state 0, it becomes 1. If previously it is 1, means it becomes 0. So that means it is toggling the output. Hence, in the truth table we are writing, when J and K both are 1 1, output is Qn bar. That means it is a toggle state. And the characteristic equation of JK flip-flop, that is Qn plus 1 equal to JQn bar plus K bar Qn. So how we are writing this characteristic equation is, just we have to simplify the expression by using this truth table. So wherever the Qn plus 1 are 1, so consider those input combinations and simplify that equation, so we'll get the final expression. So you just remember this characteristic equation, that is sufficient. Okay, so this is the JK flip-flop symbol. So this is the logic diagram and this is the symbol. J and K are the inputs and this is clock pulse. Q and Q bar are the outputs. So next, T flip-flop, that is toggle flip-flop. It's same as the JK flip-flop when J and K both are 1. T flip-flop is JK flip-flop with J equal to K. For T equal to 1, output toggles, means output complements. You can see here, we can construct T flip-flop by using the JK flip-flop just by shorting the J and K inputs. So here shorten the J and K and it's a single input now, that is T. So this is the truth table. So whenever the T equal to 0, there is no change in the output. But whenever T equal to 1, the output toggles. That is, you can see here, if T 0 means both J and K both are 0 0. So already we know that in the JK flip-flop, if both the inputs are 0, there is no change in the output. So that means T0, if Qn is 0, means the output is 0 only, and T0, if you consider initial value 1, so the next state is 1 only. That means if T equal to 0, there is no change in the output. No change here, you can see. And if T equal to 1, output toggles. That means if you consider the initial value 0, the next state value becomes 1. If the initial value 1, next state becomes 0. So that means it toggles. when t equal to 1. So here you can see in the two table. So t0 qn plus 1 equal to qn, that means no change. If t equal to 1, qn bar, that means it toggles. And the characteristic equation qn plus 1 equal to t qn bar plus t bar qn, that is equal to t exclusive or qn. Next one, d flip flop. D flip flop is JK flip flop with J equal to D and applying NOT gate between J and K, and output is same as data input, that is D. See here, just connecting the NOT gate in between J and K, and this input becomes now D. You can see here this is the symbol of D flip flop. So here now let's assume if this input is 0 now, this is not D, you can say this is D input. So now D equal to 0. So if D is 0 means J 0 and K now 1, because in between there is a inverter. So already you know that when J 0, K equal to 1, what will be the output? Just see it in the JK flip flop. When J 0, K 0, output 0. So that means this is 0, right? And if D1, now J becomes 1 and K becomes 0, and already we know that when J1, K0, output is 1. So that means if I am providing D0, I am getting output Q0. If you are providing D1, and we are getting output 1. So that means whatever the input I am providing, the same output I am getting at the flip-flop output. Hence, only this flip-flop is called as data flip-flop or delay flip-flop. So that means you can see it in the two table. If D0, output 0, that is reset. If D1, output 1, that is in the set condition. And here the characteristic equation qn plus 1 equal to D, because whatever the input we are providing, the same output we are getting. So this is about the flip-flops. In the next video we'll see the applications of these flip-flops.